Okay, so in this final video, I'm going to go for question 5 from the 2013 exam paper. So the question states there's a free-flowing sluice gate. It's 2 meters wide and it's in a rectangular channel. It generates an upstream depth of 3 meters and the gate opening is 0.25 meters. And you have to calculate 3 things. You have to calculate the flow under the gate, the horizontal force, and then you have to calculate the force, but this time only assuming hydrostatic pressure. And then compare your answer from C to that from B. So there's 3 parts to this question. So what I'm going to start off doing is just draw out the sluice gate, so it gives you an idea of what the actual problem is. So there's the sluice gate, and it's got a head of water behind it, which is 3 meters. Yep. This opening here is 0.25 meters. Yep. And the other thing it gives you in the question, it gives you B, which is equals to 2 meters. Now the first thing you need to do is calculate the flow under the gate. Now because it's rapidly varied flow, we can calculate the flow under the gate by using the energy equation and manipulating the energy equation. So that's what I'm going to do. So part A. So you've got the energy equation as y1 plus v1 squared over 2g is equals to y2 plus v2 squared over 2g. Yep. Now because we know v equals q over a, we can sub this relationship back into v here, into there and into there. So once you do that, you get y1 plus q1 squared over a squared 2g, and that is equals to y2 plus v plus q2 squared over a2 squared 2g. Now you can manipulate this further, because we know that this is b times y1 squared if you open it out, and that is b times y2 squared. Yep. So now you can rearrange this equation for q. Yep. So if you were to do that, what you'd find, you'd get q is equals to b times y1 times y2. Yep. Times square root of 2g, and finally y1 plus y2. So then that is your final equation you would come up with. Now you would use this equation to work out Q. and that's what I'm going to do. So Q is equals to B is 2 times Y1, which is 3, times Y2, which is 0.25, times the square root of 2 times 9.81 divided by 3 plus 0.25, and the answer you get from that is 3.68 meters cubed per second. Yep, so that's part A, and that is the working out and then the final answer that would give you 8 marks for that question. Yep, so that's what we'd expect you to get, the full 8 marks for that question. Part B now says calculate the horizontal force on the gate. So the horizontal force, the equation for the force is given by F equals a half rho, which is density, times gravitational acceleration, y1 squared minus y2 squared, b minus rho q, discharge, oops, and then v2 minus v1. This equation is given in the lecture notes, and it shows you the derivation in the lecture notes as well. So in the exam paper you don't need to derive it, you just need to remember the equations and then apply them. So that's why I haven't gone through the derivation, but we went through that in the lectures, and there's a tutorial question similar to this. So if you can answer this and that, you should not have any problems. So we know what rho is. Density of water is 1000. Gravitational acceleration 9.81. y1, y2 we're given, which is 3 and 0.25. B is 2 meters. Q we've worked out here. The only parameter we don't know is v2 and v1, so that's what we're going to work out. So v1 is equals to q over a, which is equals to 3.68 divided by 2 times 3 equals to 0.614 meters per second, and then v2 again equals q over a is equals to 3.68 divided by 2 times 0.25, and that gives you 7.3710 just a second. So now you have everything to work out what the force is. Yep. So if I was to write it here, so force equals to 1 over 2 times 1000 times 9.81 times 3 squared minus 25 squared times 2 minus 1000 times 3.68 times 7.37 minus 0.614. Yep. Now the answer you get from that is F is equals to 62774 newtons, which is 62.7 kilonewtons. So part B, that is the answer we would expect to get you again full marks for B. So again, that would give you 8 marks. Now for the final 4 marks, what we'd expect. So part C. Oops. So part C, what we'd expect you to work out the force, but this time only using the hydrostatic pressure. Because in this equation, what you've got the momentum and you've got the pressure force. So the pressure force is worked out by the first part, but then that is a minus from the momentum in the flow, which is for a moving fluid. However, when you're comparing hydrostatic pressure is mainly calculated for a fluid at rest. So you've got rho GH, but this time it's been times by area as well. So it be half rho GH squared times B. So rho GH times the area. So that's what you got, H squared times B. So that gives you 1/2 times 1000 times 9.81 times H. What is H this time? H will be 3 minus 2.5 because we're interested in the force on the sluice gate. Yep. So it's going to be H equals 3 minus 0.25, which is equals to 2.75 meters. So it's 2.75 times B, which is 2, and the answer you get from that is equals to 74188.13 newtons, or 74.1 kilonewtons. Yep. And the reason they're different, hydrostatic pressure, if you draw hydrostatic pressure on a fluid on a wall of a solid caused by the fluid at rest, it looks something like that. Yep. So the pressure is more because the fluid is at rest compared to when compared to this sluice gate where you've got momentum in the fluid. Yep. So the force would be less. So that is the solution to that question. That would gain you 4 marks, full 4 marks for that. To do the to do all that and then explain the difference, which is mainly because it's hydrostatic, the fluid is at rest, the force will be greater compared to when the fluid is not at rest, because it's minusing the momentum out of the flow. So in terms of the January 2013 exam paper, I've done videos for only 3 questions. The reason for that is question 1 on the 2013 paper is requires you to write a couple of sentences on fluid risk management. So it's not an analytical question. Part 2 is an analytical question, and there's a video on that which should help you. Part 3 again is analytical, so there's a video on that. Part 4 is not analytical, requires you to write a couple of sentences on the 7i equation and explain a bit about that. Question 5 again is the video that I'm currently doing, and again is an analytical question. So I've created videos for only the analytical questions, and hopefully that should provide or facilitate you in preparing for the examination. So thank you for watching.